So now these problems are going to start to get a little bit crazier in example 5. So we're going to have to look for both cases, maybe in a single function. Last time they either had the square root or they had a denominator that didn't work. This time they could be mixed and matched. So you've got to check for both of those things. So the first thing I'm going to notice is that the numerator of this one, I have a square root. And I know with a square root that the inside of the square root, 2x minus 1, has to be greater than or equal to 0. So I'm going to solve that first. So 2x is greater than or equal to 1. So x is greater than or equal to 1/2. So that right there is the smallest number that my domain can possibly be. It won't exist anywhere less than that. Okay, now I'm going to take a look at the denominator. I know that this factors. So this is going to factor to x, minus 5 times x plus 2. Okay, so this tells me, using my zero product property, that x cannot be 5 or negative 2. Okay, so x can't be 5 and x can't be negative 2. But we already knew that x couldn't be negative 2 because negative 2 is not greater than 1/2. So this part already accounts for this one. So I'm not going to include this when I do my domain. So I know that x has to be bigger than or equal to 1/2, and it can't equal 5. So here's how I'm going to write that. I know that the smallest number it can be is 1/2. So I know we're going to go from 1/2 to 5, not include the 5, and then from 5, not included, and everything larger than the 5. So what this says is x has to be greater than or equal to 1/2, so it goes from 1/2 to 5, doesn't include the 5, and goes to infinity. Okay, so as we go through, make sure you're aware of what that notation means, and if you don't understand, make sure you ask me a question in the messages or the discussion board on Canvas so that you can understand what's going on. So again, let's take a look at B. So in B, the top of this one, okay, 6t, there's nothing I can plug into the t that's going to make this function not exist. So the top is good. The bottom, though, has a square root in it, right? And we said that normally 4 minus 7t, so whatever's inside the square root, has to be greater than or equal to 0. But what happens if the denominator of this fraction is 0? Well, the denominator of the fraction is 0 means that the fraction doesn't exist. So this one cannot be or equal to. This one just has to be greater than. So make sure you look for that. If the square root is in the denominator cannot be 0, so it's got to just be greater than 0, okay? So let's solve this out. So 4 is greater than 7t, divide by the 7. So 4/7 is greater than t, flip it around like I like to. So I know that t has to be t has to be less than 4/7, okay? So you can leave it like this, or if they wanted an interval notation, which this one says or, I would probably leave this one like this, but an interval notation that says t is less than 4/7, so that's everything from negative infinity to 4/7. So that's what this would look like in interval notation. Taking a look at C, C on the top has a square root, so I know that negative x has to be greater than or equal to, because this time it's on the top, greater than or equal to 0. So I need to divide by negative 1, and if you remember back your rules for inequalities, if you divide by a negative, the sign flips. So this is going to be x is less than or equal to 0. So x has to be smaller than 0 this time. Okay, so that's done with the top. Let's look at the bottom. I know that the bottom can't be 0, and I'm just going to use some common sense for this one. If I square something, anytime I square a number, I'm going to get a positive number. If I have a positive number and I add 5 more, this number is just going to get more and more positive, okay? And there is nothing that I could plug in for x that would make this denominator be 0, because even if I plugged 0 in for x, this piece would go to 0, but then I'm adding 5 more. The only thing that would work would be if this term were negative 5, because that would give me 0, but if I square something, then this piece is never going to be negative. So my bottom is fine. So the only thing that I need is for x to be less than 0. So x is less than or equal to 0 looks like this. Okay? So hopefully that makes sense. Sometimes you're going to have to use a little bit of logic to make your life a little bit easier. Take a look at letter D. On the top, nothing, so we're good. On the bottom, I have a square root that I know can't be 0, and I know has to be positive. But again, look at my square root. If I square something, that is going to be positive. If I multiply a positive number times 5, I'm going to have a positive. If I add 3 to my already positive number, it's just going to keep getting more and more positive. So the denominator is fine. So this is all real numbers, which looks like this, okay? So make sure you're paying attention to some things that you can just figure your way through, okay? Okay, look at this one, my top. I have this one. Now this one is going to have some issues. So 5x minus 3 is greater than or equal to 0, and it's or equal to because it's on the top. So 5x is greater than or equal to 3. So x is greater than or equal to 3/5. So 3/5 is my low point, okay? Looking at the denominator, this factors. So this is x plus 3, x minus 1. So I'm going to have an issue at -3 and at 1. Well, again, -3 is not greater than 3/5, so I don't really care. But 1 is greater than the 3/5. So x is going to go from 3/5 to 1, not include the 1, and then go from 1 to infinity. All right. Taking a look at f. F is almost the same as E was. So the top, I'm just going to use the fact that I already solved this. So I know that x has to be greater than or equal to 3/5. Same problem. Okay. The bottom factors, so this is x plus 3, x plus 1, right? So that means that x cannot be -3 or -1. Well, both of these guys right here are not greater than the 3/5. So since they're not greater than the 3/5, they don't need to be included in the domain because this one kind of supersedes that. So this one is just 3/5 to infinity. And that's what I think they're trying to get you to see. This problem right here, you don't need to include those, where on this one you had to include the 1. So just make sure you're paying attention, all right? Same thing over here. So I've got 5x minus 3. It's the same problem. So again, I'm just going to go back to what I already did to not waste your time. But look at the bottom this time. The bottom this time factors to x minus 3, x minus 1. So that tells me that x can't be 3 or 1. And both of those numbers are greater than the 3/5. So I have to account for them in my domain. So I know that 3/5 is the smallest we're going to go. I know my first problem that I'm going to encounter is at 1. Then I'm going to have to go from 1 to my next problem, which is 3. And then from 3, there are no more problems. Okay? So you're going to make sure you take care of that when you're doing domain, when they have multiple things that happen. Okay? While we're on this, let's go ahead and take a look at example 6. We're going to find the domain of all of the following, so we're still looking at our same things. But take a look at these. This time I have x squared. Yes, I've got a square root, but it's just the square root of a number, and this is just an x. So do you see that this is just a quadratic? This is just a normal polynomial function. This is a polynomial, okay? And polynomials are always -infinity to infinity. You have a squared, you have a first power, you have none. You might have x cubed, x squared, x to the first, none. Anytime you see that, it's a polynomial. Polynomials all exist for all domain, okay? Look at this guy. If you have an exponent, if I plug things in for x, if I plug in a negative number, remember if I had, like, let's say it was 4 to the -2, remember that just means it's 1 over 4 squared with our exponent rules. So those exist all the time. If I had 4 to the 0, any number to the 0 power is 1. And if I plug in a positive number, well, any number to a positive power is just whatever that number is raised to that power. So like 4 squared would be 16. So this is going to work for everything. So this is -infinity to infinity. So again, think about what things can exist and what things can't exist. Looking at C, normally you see a root and you go, oh, this has to be greater than 0. But look at this root. This root is odd. Odd roots always exist. Okay? Odd roots always exist. You're not worried about them being positive or negative. They always exist. The only thing you would have to look out for is if this was in the denominator. Because if it's in the denominator, you know it can't be 0. But it's on the top, so it's fine. Then look at the bottom. This is just a number. It's a gross number, but it's just a number. So you have some number over some number. That's fine. You don't have any issues there either. So make sure you're being aware of what does exist and what doesn't exist, and look for those.